Well, good afternoon. Once again, my name is Ken Reitler. I am the Robert A. Heinlein Distinguished Professor of Aerospace Engineering here at the Naval Academy in the Aerospace Engineering Department. It is indeed my distinct pleasure and honor to moderate our final panel of today. This panel will focus on commercial spaceflight pioneers. Quite a remarkable new direction in our way we're approaching space. And we have a very, very distinguished group of people to speak to it. People that definitely meet the criteria of pioneers within this new and burgeoning marketplace. I will remind you that we will have a question and answer session at the end. And so if you do have a question, please use one of the microphones at the top. But if you can't get out to do that, please stand at your seat, speak loudly. We still have a big room that needs to be filled. Right now, I'd like to introduce our moderator for this panel. We're honored to have Captain Michael Lopez Alegria, who is a Naval Academy graduate, class of '80, to be moderating. I think we have a few members of your class here today. Currently is the president of the Commercial Spaceflight Federation. He comes from a distinguished background in aerospace, which includes positions as a naval aviator and test pilot, NASA astronaut, and International Space Station commander. Mike, or LA as we call him, received his Bachelor of Science degree here in Systems Engineering, and he also got a Master of Science degree in Aeronautical Engineering from the U.S. Naval Postgraduate School. He's also a graduate of the Harvard University's Kennedy School of Government Program for Senior Executives in National and International Security. He speaks Spanish, French, and Russian, speaking to the culture and the kinds of things that you need to be able to establish relationships with people to do international programs. He has over 3 decades of experience with the U.S. Navy and NASA in areas of naval aviation, naval engineering, as a test pilot and program manager, as I said, an astronaut and station commander, and also the assistant director of flight crew operations. He's flown on many shuttle missions, STS-73, 92, 113, served as the commander of Expedition 14 on the space station, which he flew up and back on a Soyuz TM-A9. He holds 3 NASA records: longest space flight, 215 days, most EVAs or spacewalks, 10, and cumulative EVA time of 67 hours and 40 minutes. So when you watch that movie, Gravity, and you see those people out there in that suit, think about spending 67 hours, almost 68 hours. LA has most recently served as the assistant for ISS to the director of flight crew operations at NASA's Johnson Space Center. Now, on a personal note, not so fast. One of the most difficult things as astronauts, the choices that we make when we get ready to fly, is who will look after our family in the event of something goes wrong. Being given that assignment is seen as the highest confidence one that can be given. For our crew of STS-60, Mike L.A. was that person. We are extremely honored to have him moderate our final panel today on commercial spaceflight.
Do I get 5 more minutes after that? Well, listen, the hardcore folks are still here. It's truly an honor to moderate this panel. There's some wonderful examples of commercial spaceflight here, but also to having shared the stage with the folks that preceded us, the other 2 panels, General Tom Stafford this morning. We were all sort of standing on the shoulders of these giants, and it's a great view from here. I want to thank Admiral Daly, April and Karen and the rest of the U.S. Naval Institute staff for the invitation, Vice Admiral Miller for the hosting of this great venue, and my buddy Ken Ham, whom I don't see right now, for putting this whole thing together. He was kind of the man behind the curtain here. And I guess my only regret is that I sort of had to follow a couple of pretty good panel moderators, I think you'd agree, and David Hartman and Miles O'Brien. And if I'd taken up Hawk on his invitation to come over and have some scotch and a couple of cigars, I might have the same kind of voice that David Hartman has all the time. Anyway, so we're here to talk about the past, present, and the future. We certainly heard the past and a bit of the present today with the previous panel on the ISS. This panel is going to be a little bit different. My ROE is that I'm going to have each of the panelists say a few words about the companies that they're representing. And the reason is that while some of the other panelists could sort of tell stories, the stories haven't been written yet. We're kind of in the middle of writing those stories, and I'd like to give them a chance to kick that off in prose. The other thing I wanted to mention is that we're sad to not be joined up here by Major General retired Charlie Bolden, who was supposed to be on the panel due to circumstances that I don't think I need to get into. He couldn't join us, but he did have something to say, which I'll just read to you a bit later. So I want to start with some brief comments of my own, and I think I'd call this Commercial Spaceflight 101. And what is commercial spaceflight? There's a lot of ways to define it. There are a couple of ways that I think it's sort of some parameters that you could parse out the different aspects of it. One is, where are we going in commercial spaceflight? We're going to space. What is space? Somebody defined it by the Kármán line, which is arbitrarily 100 kilometers, about 60 miles. Above that, you basically cannot sustain lift. So the only way you can stay out in space is by going fast enough to stay in orbit. Otherwise, you're coming back. Because although, and this is for the bull majors, that is the non-STEM educated folks in here, at an altitude, orbital altitude of about 250 miles where the ISS is, there's just about as much gravity as there is here. The problem is that you're going so fast, 17,500 miles an hour, about 5 miles a second, you don't really fall back to the Earth, you fall around the Earth. So we're going to space, but are we going orbital or are we going suborbital? Those are sort of the two realms that commercial space talks about. For orbital velocity or for orbital flight, you need the velocities that I just mentioned. You also need to get out of the atmosphere, because if you don't, all of the drag from the atmosphere will slow you down. So if you ever see a time-lapse photography of a shuttle, or any launch for that matter, they go up at first and then they sort of bend over and they go parallel to the surface of the Earth, and the whole probably 3/4 of the rest of the trajectory is just trying to get speed. Suborbital, on the other hand, is a different game. Suborbital is anything from, let's say, what Alan Shepard did in 1961 to what some of these companies are trying to do now, which is basically go straight up and straight down. So now technically, whereas you need to go Mach 25 to get to orbit, you can go a lot slower to get to suborbit. In fact, there really is no minimum speed to get to suborbit. As long as you have greater than 1-to-1 thrust to weight ratio, you can go as high as you want. But in practice, it ends up being about Mach 3-ish to get up there. So it's a pretty different problem, technologically speaking, between orbital flight and suborbital flight. Another way of sort of parsing out the realms of commercial spaceflight is who or what is on board. So it could be unmanned, which could be cargo, which is destined for the ISS, which could be food, clothing, water, fuel, that sort of thing. It could be commercial satellites. They could be defense satellites. It could be science and technology experience. Or it can be manned, which means people, which could be for a couple of different things. Tourism is one. Again, research, scientists attend the payload, or foreign sovereign clients, which you talk about in a little bit. So commercial means commerce, and commerce means making money, and that means you have to have a business model. And that means you have to have a market. So the suborbital market is pretty well understood. There's an outfit called the Torrey Group that did a study that was commissioned by the FAA and Space Florida, who was a space-related economic development outfit in Florida, that looked at the suborbital market over the next 10 years. And they came up with 8 different markets, 6 of which they deemed were viable today. And of those 6, about 80% of the revenue they expect to be based in space tourism. So these are people who have signed up with companies like Virgin Galactic or Xcor Aerospace, over 1,000 of them. Just to give you an idea, there are about 550 humans that have been to space. They could probably double that if they sign up, if they fly all their clients that have signed up. So, and those people are paying somewhere between $100 and $200 or $250,000 each to fly. So there is a market. A very conservative estimation of that tourism market, or sorry, of all those markets together, says that in the next 10 years it may generate about $600 or so million. There's a growth scenario where it's 3 or 4 times that. So I think that market is pretty well understood. So 80% of it is tourism, about 10% is research and development, science and technology payloads, and then the other 10% is made up by the rest. The orbital non-human market is also fairly clear, satellite launches. So there's been a market around that for 20 or 30 years. The U.S. has not done very well in it, particularly lately, but that's turning around, and you may hear a little bit more about that from one of our panelists. But the orbital human market is a bit more tricky. While tourism does have unsatisfied demand, so I flew up to ISS and flew home from ISS with 2 different space tourists. They paid somewhere between $20 and $35 million with an M to fly up there. They spent about a week up there and came home, and there are more people that want to fly than there are seats available. So that piece is there, but you can well imagine that the number of folks with that kind of disposable income is not that high. So the biggest known market right now in the orbital manned side is the US government, and that's through something called the Commercial Crew Program, which I'll talk about a little bit more. So another way of defining what's commercial is kind of what it isn't. So what it isn't is when the government does a cost plus fee contract with a provider. Typically they're sole source. The government is involved in every decision that's made in the design process for development. So Mercury, Gemini, Apollo, Saturn V, Space Shuttle, ISS, all of those fall into that category. And that has its place. It's useful when things are sort of right on the edge of technology, where nobody's ever done it before, and most importantly, where there's no market. What it is, commercial, is a different kind of contracting mechanism, which is fixed price, milestone-based, competitive, less government. So instead of saying, this is the widget that I want you to bring, and here's how you're going to bring it to me, they say, just bring me the widget. As was it General Tom mentioned this morning, somebody was talking about a one-page RFP. Well, that's the ideal. I don't think we'll ever get there again. But the difference there is that the contractor makes the decisions on how to do it, and therefore the government's out of the way, if you will. Things go a lot faster and cheaper. Just to give you an idea, something called the NASA Air Force cost model showed that the Falcon 9, which is a SpaceX launcher vehicle, costs about $450 million versus it would have cost about $1.4 billion under the old style cost plus fee contract mechanism. So the question is, should government funding be used for commercial, especially if the contractor gets to keep the intellectual property? Well, I think it depends on the market. In the suborbital world, is very relatively small share of the market that's where the government is a customer, and therefore the investment is correspondingly less. But in the orbital market, where the government is right now at least the only confirmed customer, their investment has to be quite a bit more. But beyond that, I think we should consider one thing that's pretty important, and a couple folks touched on it today. Right now, if we want to launch an American astronaut to the International Space Station, we have to pay the Russians to do it. We pay them about $450 million a year to do that. I did that. I was glad to have had that experience, but I was a little sad and kind of embarrassed that my country didn't have this. So I would like to see us restore that national strategic imperative, and I look forward to hearing from these panelists in front of you that are going to make it happen. All right, end of my comments. Let me just read to you a statement that Charlie Bolden, so if you don't know, Charlie Bolden graduated from here in 1968. He was a combat aviator, test pilot, became an astronaut, flew 4 times on the shuttle, a couple very important missions, including deploying the Hubble Space Telescope, and then also flying with Captain Reitler, as he mentioned, on STS-60, the first cooperative shuttle mission between the US and Russia. He also had lots of important ground-based technical assignments, including overseeing the safety efforts during return to flight after the Challenger accident. After leaving the agency in 1994, he went back to the Marine Corps, had several leadership positions, finally retiring as the commanding general of the 3rd Marine Aircraft Wing at Miramar, and is now the 12th administrator of NASA, where he runs the whole show, which includes about 18,000 people and about $17 billion in annual budget. So here's his statement. Please accept my sincere apology for being unable to be with all of you today for this very special Naval History Conference. The government shutdown prevents me, as well as our active astronauts, from participating today. I do wish to express my deep appreciation to the Naval Institute CEO Peter Daly and Naval Academy Superintendent Vice Admiral Mike Miller for hosting this conference on the past, present, future of human spaceflight. Thanks to all of you who have come to participate as speakers and panelists, especially these on the commercial spaceflight panel to my right. Allow me to acknowledge the recent successes of 2 of NASA's commercial cargo partners, Orbital Sciences and SpaceX. With last Sunday's successful berthing of the Orbital Cygnus cargo module to the ISS, we have expanded America's capability for reliably transporting cargo to low Earth orbit. This follows on the heels of 2 recent SpaceX cargo missions. We now have 2 commercial cargo partners who are freeing NASA to focus on the technologies to reach an asteroid and Mars. The nation's space policy is aimed at creating an environment where commercial space companies can build upon past successes, allowing NASA to focus on the administration's ambitious path for deep space human exploration, which includes sending astronauts to an asteroid for the first time and ultimately to Mars. The increasing number of private U.S. companies attempting to push the boundaries of space shows the wisdom of this policy. Developing a private U.S. capability for crew services also remains a top priority for NASA. 3 U.S. companies, SpaceX, Boeing, and Sierra Nevada, are currently developing systems under funded agreements with NASA. Our goal is to begin launching astronauts to the ISS from U.S. soil by 2017. Any reduction to the proposed level of funding to the commercial crew program would result in a delay in bringing these launches back to America and force us to continue paying the Russians millions of dollars to get our astronauts to space. We are not helped by the current shutdown that will likely threaten our ability to make the already delayed operational readiness date for commercial crew. NASA remains in the future business, and what you will hear from this panel today is our collective vision for the future of this great nation, still the leader in exploration of our universe and of scientific discovery. I join the panelists in expressing our hope that we will leave you as excited and optimistic about the future as we are. Best wishes for great discussion and success in all your future pursuits. Go Navy, Charlie Bolden, USNA Class of 68. With that, I would like to begin to introduce each of the panelists for them to give a short presentation, and then we'll open it up for discussion. I'd like to encourage the few midshipmen that are left to chime in, because really this is in no small part for your benefit as well. So the first speaker is Frank Culbertson. Frank is Executive Vice President, General Manager of his Advanced Programs Group for Orbital Sciences Corporation in Dulles. In his capacity, his responsibilities include execution and performance of all of Orbital's programs related to human spaceflight, including the Commercial Orbital Transportation System, as well as multiple national security space-related projects. Prior to this position at Orbital, Frank was a Senior Vice President for Human Space Systems, and before that, a Senior Vice President at SAIC, following an 18-year career as a NASA astronaut. He's flown in space 3 times and logged over 144 days as a space shuttle commander, pilot, and then later station crew member. His last mission was on the shuttle Endeavour, lasted for 129 days. During that mission, he lived and worked aboard the ISS for 125 of them and was a commander of it for 117. He's had several key management positions within the NASA shuttle and ISS programs, as well as program manager of the Shuttle Mir program that we heard earlier. 1971 graduate of the Naval Academy. He's a naval aviator, fighter pilot, test pilot, lots of awards and accolades, retired from the Navy as a captain in 1977, and a member of the Astronaut Hall of Fame as of 2010. Please welcome Frank Culbertson.
Thank you very much, Michael. Thanks for the introduction, and thanks to all of you for being here, and certainly thanks to the Naval Institute for hosting this and furthering our knowledge in this community by having us have a chance to talk to each other, but most especially to talk to you. And I want to thank Admiral Miller and the entire Naval Academy staff, including those who are not here today, for having us on board. Before I go any further, is that a camera on your eye? Or are you a robot? What? Really? Okay. First time I've seen that. Talk about spies. But it's just a little disconcerting. You see this little thing pointing at you. That's all right. I've had worse. To continue just a little bit with some things that were said on the previous panel before I get into discussion of where we are at orbital and in commercial spaceflight, I'd like to just mention a couple of things that were I thought important about what was talked about earlier, particularly between Shep and George and Ken. You know, spaceflight is a very special experience, and all of us who have done it are truly privileged to have had the chance to participate in that. And as has been said earlier by Bob and others, that we're really just the tip of the spear. Lots of people make it happen, but there are a few things that happen that you got to be there to experience it. My first mission was a classified mission for the Department of Defense, and Dick Covey was my commander. He'd flown in space before, so we looked to him as the experienced hand on board. And we launched at night after actually about 4 months of trying to get off the pad, but we launched shortly after sunset, so it was fairly dark as we left the environment of the pad and the spotlights, or floodlights and everything. First 2 minutes of the flight are pretty rough. You're on the SRBs and you're being pushed back into your seat, and you're trying to focus on the gauges and try to remember all the things you're supposed to do if something goes wrong. And all of a sudden, the SRBs quit. The thrust feels like it all goes away. It gets very quiet for a couple of seconds, and then bang, the solid rockets blast off the side of the external tank with the explosive bolts, and these big tongues of flame go shooting across the windscreen in front of you. And I went, wow, is it supposed to look like that? Covey said, I don't know. I never launched at night before. But they fell away, and we had a very smooth ride uphill and got on orbit. And as we were going through the checklist and being the PLT on the right side, my job was to not get sick right away, and then also to turn off the APUs and a few other things. And so I'm trying not to disorient myself. And these were the days where we entered orbit inverted. And so I'm looking out the windscreen periodically and getting used to being in 0G and my head filling up with fluid. And I looked up, and we had launched during Desert Shield, which some of you may remember, in the fall of 1990. And I'm looking across the horizon because we're about to, we've gotten across the Atlantic fairly quickly. And I saw this really bright light coming up fairly quickly, and I thought, man, we just launched and they're already shooting at us. And what it was Venus, which was a very bright circle when you're in orbit. And then that was followed by a tiny little sliver of moon. In orbit, you can see, even if it's a brand new moon, you can see the entire outline of it, the reflection of the sun on the backside. And I'm thinking, this is really pretty. And then I thought there was a volcano starting to erupt on the horizon because there was a bright red light, and then it started kind of almost bubbling in the clouds and then spreading out in all directions, and all the colors of the rainbow started spreading out. Boom, the sun popped up, and I was seeing my first sunrise in space. And I turned to Covey again, and I said, wow, is it always like that? That was gorgeous. And he said, oh, yeah, every 45 minutes you'll see another one. And but you never really get tired of it. And it's just something that makes it real for you that you are, in fact, in space, because those things do occur, and you realize that you're one of the privileged few to be able to see that. The other thing I learned in flying on both the shuttle and the space station is, and this has been mentioned too, the shuttle really is like an aircraft. You take off, you do your job, you come back and land, turn it over to somebody else, and they take care of it. They work on it in the hangar, and then it gets ready to go again. A lot of what we do is commanded real time, and I had an exchange tour with the Air Force back in the 70s, and that was a lot different than flying in the Navy, because everything we did, we had to call back to the command post and talk to them about it. In the Navy, you took off, you did your mission, you came back and landed, and then asked forgiveness or explained things later. But we really did have to talk about everything on the shuttle. Once you got to the station, particularly in the early days when I flew, we didn't have real-time communications all the time, so we did have to be somewhat autonomous. And the other really important fact is, it's like being on a Navy ship at sea, particularly before the days of a lot of satellite communication and the ability of the Pentagon to meddle in what you're doing. But you really have to be ready to take care of what's going on your own, given that you may not be able to talk to the ground. And you've heard some examples of that today. So the station is on a long voyage, and it's got a very competent crew with a pretty good support system back ashore, but they still have to be ready to operate like a ship. And the crew has to be ready to operate as a team that's on a ship that can solve their problems. That being said, we are preparing for longer missions, longer journeys. And we in the commercial spaceflight world, and basically that's everybody who builds aerospace hardware, as has been pointed out, all of our hardware has been built by commercial companies, are proud to be a part of that, and we feel we'll be an essential part of it. And in low Earth orbit, we are trying to provide both cargo and crew transportation so NASA can concentrate on the job of exploring further and taking things like the Mars mission and making it real. Orbital, who I have the pleasure of working for now, has about a 32-year history. It was founded by David Thompson and two partners in his bedroom out in California a long time ago, based on a paper the three of them wrote for an MBA at Harvard, and an angel investor who came along with about $50,000 here and said, let's see what you can do with this commercial space idea. And so they started from there. It took a while. Their first commercial launch actually was the Pegasus, dropped from a B-52 by Gordon Fullerton, a former astronaut, and it worked. It didn't work every single time in the first 10 flights, but we now had 42 successful flights with Pegasus as a small class launcher for small satellites. And Pegasus has actually taken a satellite as far as the distance to the moon and into a solar investigation orbit well away from the Earth. So it's been a great success for the company. But over the years, we've developed other launch vehicles. We developed target vehicles for the military, as well as some interceptors for the ground-based missile defense system. We also build satellites for commercial companies such as SES, communications companies such as SES, and commercial companies all around the world, and have had a number of successes there. Science satellites for NASA and NOAA, and recently Landsat 8 was commissioned, and that's an orbital satellite. And in fact, we have about over 1,000 years of actual on-orbit operations time under our belt, and between all the satellites that we have deployed. And so we've got a lot of experienced people that have done this and are committed to it, and a good diversity in our portfolio in that regard. We've also done a good bit of national security work, and I can tell you about as much about that as I can about STS-38. Recently, some of you may have had the chance to see our Minotaur 5 with Laddie on board, launched from Wallops Island, just a little bit southeast of here, about 90 nautical miles. That was seen all up and down the East Coast. It's not a very big rocket, but it's pretty bright when the conditions are right. And that was a proud moment for us. That was a real happy moment for me because this was one of Ron Graby's vehicles out of the Launch Systems Group. And Antares and my Cygnus spacecraft were actually waiting in the wings to go once Laddie got off the pad. So the sooner they went, the sooner we went. And so I was pulling for them real hard. But it took about 12 days in between the two missions to recycle the range and get everything set. And we finally launched Antares for the second time in its history on September the 18th from Wallops. That was a daytime launch, so it wasn't quite as visible as the night launch of the Laddie mission. But a good many people still saw it, and I think some of the folks here, I think Captain Ham took some folks out to watch it from an illegal spot on the roof somewhere, right? That's what I heard. Fortunately, nobody fell off in the excitement. But I was in mission control for that one, or launch control, and it was a very exciting time for the team. The first launch, the test flight back in April, of course, was also very tense. It took us 3 attempts to get that one off for a variety of reasons, but we fixed them all, and this last countdown went very smoothly. So it was a very proud moment for us to see it lift off. Cygnus was the spacecraft being carried. We had christened it the SSG David Lowe in honor of one of our colleagues who had been a member of my astronaut class and who had actually worked for Orbital for over 10 years and was actually one of the authors of this particular system to carry cargo into space at Orbital. He passed away from cancer about 5 years ago, and so in order to honor him, we named the spacecraft after him. And the crew was kind enough to acknowledge him when the spacecraft arrived aboard. We had planned on rendezvousing with the station Sunday a week ago, what would have been the 22nd of September. However, we ran into an interesting issue between ourselves, our GPS on board, and the Japanese GPS that we use for relative navigation on board the station, and we had to correct a data exchange flag that wasn't set properly. And so in the process of doing that, we discovered another issue with the software that we needed to refine and get NASA comfortable with before we came back and revisited. In the meantime, the Soyuz was ready to launch, and so we went away, actually about 2,000 kilometers. The Soyuz came, docked with the station, brought the crew of 3 on board, and then they cleared us back in hot. And so we took about 3 days to return to the station, joined the R-bar, which is the axis between the station and the center of the Earth, flew up that, flew back, flew up, flew back to demonstrate all of our abort and hold capabilities, and then finally made the final approach, which went very, very smoothly. We're very proud of the way the vehicle worked, but mostly we're proud of the way the 2 mission controls worked together and brought them safely to a stationary point about 10 meters away from the station. Luca, the Italian astronaut on board, had the privilege of grappling G. David Lowe and bringing it on board. You might ask why the Italian and not Karen. Well, he was, being Italian and the fact that our cargo module was built in Torino, Italy, I think he wanted to have that connection. After they had berthed it and safely and removed the insulation and opened the inner hatch, you could tell Luca was really anxious to get inside that thing, but they made him wait till the next morning. And I do have to violate the rules a little bit. Mike told me that I couldn't have any slides, but I'm not very good at following directions. So if I could have the handful of slides. This is my favorite shot of the launch of the Antares. You know, Mars, the Mid-Atlantic Regional Spaceport, is actually owned and supervised by the Virginia Department of Transportation, and they were kind enough to put one of their green and white signs right there by the ramp leading up to the pad. And but that kind of says it all, you know. The sign next to it that you can't see in the picture actually says, "To the moon." And that went to the Laddie pad. This was an artist's rendition of what it was going to look like, and this is what it really looked like as Cygnus approached, and it was a really happy day, but you could hear a pin drop in Mission Control and in the auditorium and in all of our facilities where people were watching until it stopped and they got a safe grapple and capture of the spacecraft. And then when they opened the hatch, there's the orbital logo, but more important, there's G. David Lowe's astronaut picture. And there's a couple of pictures of his family that went up that we hope will, Tim, we hope you guys will bring back for us. Do you mind? On a SpaceX return flight. So you can see it's a pretty roomy module. We can carry up to 2 tons in this particular version, 2.5 tons in the next version that'll start flying in late 14, early 15. And we think the crew is going to like it because it's designed for cargo. We did throw a couple of extra little goodies on board. Remember Luca's episode with the water in the helmet? Well, that's a snorkel he's pulling out of there. And he was pretty happy to receive that in case he has to do another EVA. And we sent some M&Ms up with the proper logo on board, so the crew was happy to find those. I know from experience chocolate is always welcome on board. And so we are very, as I said, very proud to be a part of this. We think that the future of the ISS depends on commercial spaceflight, crew and cargo. We think that the future of the ISS is linked to the future of human spaceflight in the United States in an even more important way now, because my view is that if we don't continue to support ISS in all ways necessary, the generation that's at the Naval Academy now will not have a human spaceflight program. They'll have to wait till the next generation if we shut this one down. It's very important that we as a country keep this going, that we as international partners keep this going, and I think the entire world will depend on it. People don't pay nearly enough attention to it. The things that we do in space, in aerospace, don't get the attention we would all like, but I have to tell you, in my company and in all the companies represented here, the people that are doing the work there and at NASA and elsewhere are there because somebody motivated them to get involved in science, technology, engineering, or math in school and to stay with it. And because these are the people that when math got hard didn't quit and go to history. Where's Miles? Or something like that. I mean, not that history's bad, but it's very important that we keep motivating people that this is an exciting way to go, an exciting job to have, and it's extremely important to the future of the country. I think all of us here would agree that we have to keep pushing that. NASA does a good job of pushing that. The Naval Academy and the U.S. Naval Institute, I believe, whether they even think about it or not, are pushing and motivating people to be involved in STEM, because the midshipmen here don't all major in those 4 areas. They major in other things, but they wouldn't be here if they weren't capable of dealing with STEM subjects and capable of working with people who are. So it's important we keep communicating about this. It's important we keep funding it as a country once we get the parks back open. But it's really important that we give the next generation a place to go. My view when I was on the space station, and it was much smaller then, was that I could, if I had the propulsion, I could take everything I had there and go to the moon with it and survive on the surface of the moon if I had a way to get it down there. And then thinking beyond that, with a few more modules and a little more cargo, I could go all the way to Mars. But it's going to look something like that. It's going to feel something like that. And the operations are going to be a lot like going on a long voyage on a ship. So you all are at the right place to get ready to go far in space. Thank you very much.
So Frank, no slides, there's always one, right?
Hey.
So we're going to transition now from somebody who's involved in the NASA commercial cargo world to the next 3 presenters who are in the NASA commercial crew world, as well as the last one, Tim, is involved a little bit of both. And then Brett, representing Blue Origin, also has some non-funded space agreements with NASA. So all the folks that you see here are involved with, in some way or another, with the commercial space aspects of NASA. The next 3 are focused on the crew. So representing Boeing is John Elbon. He's their Vice President and General Manager of Space Exploration, which is a division of Boeing Defense, Space, and Security. He's responsible for strategic direction of Boeing's civil space programs, support of NASA's programs such as the ISS, Commercial Crew Initial Capability, and the Space Launch System. He's been working on Boeing's human spaceflight programs for 31 years. Previously, he was a Vice President Program Manager of the Commercial Crew Programs, Vice President of System and Integration for the Army's Future Combat Systems, and the Boeing Program Manager for several NASA programs, including Constellation, ISS, and the Checkout Assembly and Payload Processing Services contract at KSC. As a Vice President Program Manager of the ISS, he led Boeing in its role as prime integrating contractor for NASA's ISS contract to design, develop, test, launch, and operate the orbiting laboratory. Multi-billion-dollar contract required the coordination of several thousand Boeing employees in 5 major locations, as well as subcontractors and suppliers located in 23 states across the country. He has a Bachelor in Aerospace from Georgia Institute of Technology. John.
Thanks, Michael. Yeah, that was good, Frank. There's always one. It's usually you. So I guess I'll introduce myself and maybe my 3 teammates down the table here by saying I didn't graduate from the Naval Academy. I haven't flown in space, but I did sleep in a Holiday Inn Express last night. And we're going to design the next spaceships that will carry the next astronauts in space. And I think that's important. Hey, I wanted just to comment a little bit on LA's comments on the market and then tell you a little bit about what Boeing's doing in the commercial market. So I think we're on the cusp of a commercial market in space. It's a matter of how fast it will materialize and when. As LA explained, certainly there's public interest in participating in suborbital and onto orbital. We're getting incredible science out of ISS now, and there's potential that that could turn into some kind of a commercial market in space at some point. And I think the challenges and technologies that are required to go into low Earth orbit in particular are well enough understood. We've been doing that since John Glenn did it 50 years or so ago. And so, industry-led transportation to low Earth orbit is certainly a viable thing. So we're on the cusp of all that coming together. Boeing has had some unfortunate endeavors in commercial space that cause us to take pause a little bit. Delta IV, we wrote off $2.5 billion developing that program, believing that there were going to be constellations of satellites in low Earth orbit that we could put into orbit and make a business case out of. And that didn't materialize, and so that was a bit of a challenge. Sea Launch is another launch vehicle, about $500 million in that particular launch vehicle. And then we purchased the Hughes communications satellite company that was working a lot of commercial satellites. That market tanked a bit, and that was $2.5 billion. So if you add all that up, there's been a significant investment in commercial space that didn't realize a return. So it's very important for us to go into this cautiously, I suppose, make sure there's a market there, and invest wisely for our stockholders. So is now the time? I think it is, and there's a couple of reasons. There are some clear markets. The commercial participants to space station, 7 individuals have gone on a total of 8 trips, and they paid real money to do that, and there are more interested. Eric Anderson, who runs Space Adventures, has a pretty good list of folks who are interested in traveling to space in a similar manner, and so that's a market that can be explored. We've also worked quite a bit with Bob Bigelow and Bigelow Aerospace. His market is countries that can't afford their own space station, their own space program, but certainly have the wherewithal to invest in sending their astronauts up for some number of weeks or months to do research in space as a way of moving their country into the spacefaring nations. But importantly, as L.A. described, NASA has put together a program that is going to enable this, investing in our development and then serving as kind of the foundational customer for these transportation services, allows us to build a business case that has a limit on the downside risk, I'll put it that way, but a potential for a significant upside risk should these markets, when these markets mature and become a part of the whole scheme. So I think it's just a brilliant approach that's been put together. There was a lot of work done, NASA talking to all of our companies to help shape that approach, and I think what's resulted is something that's we're going to be able to develop a capability that will serve NASA's needs and stimulate the growth of a market beyond those needs. So I'm just real excited about that. So let me just talk then about Boeing's, the vehicle that Boeing is designing to bring into this. We call it CST-100. CST is commercial space transportation, and the 100 is the 100-kilometer threshold of space that was described earlier. And so that's where that whole thing came from. So we're trying to take, if you look at the spacecrafts that have carried humans into space up to this point, we were involved in all of those in some way. Mercury, Gemini, Apollo, Shuttle, Station, all those were vehicles that Boeing played a significant role in developing. And we're trying to capture the skills and knowledge that we used on those programs and put them into an environment that can be more efficient, more effective, more affordable going forward. So our real focus is on a vehicle that can be safe. It's got to be safe first, reliable, so that we know we can do this transportation in a routine way, and affordable, so that it enables a commercial market. It enables transportation to station in a way that NASA then has resources remaining to do exploration beyond station. So the vehicle design is a capsule. It is based on the shape of the Apollo capsule, and it will launch on an existing launch vehicle. The first missions are going to launch on an Atlas V. I mentioned it's an Apollo mold line. We did that because we can understand the aero and reduce the risk associated with that. And we're reusing a lot of systems as we build this to make it more reliable and affordable. For example, the automated rendezvous and docking system is a system that was used on Orbital Express, an uncrewed DARPA program that did automated rendezvous and docking in low Earth orbit. We're using the thermal protection system derived from a shuttle and Apollo. And there are some places where we've chosen to insert innovation. For example, we have a pusher abort system rather than a tractor abort system like was used on Apollo and Gemini. That allows us to use that fuel on orbit if, assuming that we don't have to do an abort, and generally that's how ascents go. And our pressure vessel is made from a spun-formed dome so it has 0 welds in it, and that greatly reduced the cost associated with fabricating that structure and doing the and non-destructive evaluation associated with testing it before it's ready to go. The critical, maybe the most critical part of the flight is ascent. And so we chose to select a launch vehicle, at least for the early flights, that had a robust and proven launch history. So the Atlas V has 39 successful missions, and each time it launches, we get another test of our launch vehicle system, and that's adding to the safety and reliability of the integrated system as we go. It's being modified with an emergency detection system, so if there's a problem during ascent, the capsule will know and the abort system can be engaged. And it's also, of course, we'll have to modify the pad with a crew access capability so that we can get the crew into the capsule. Having said that, we're designing the capsule so it'll be compatible with other launch vehicles as they come along. So as other launch vehicles are proven reliable and are better from an affordability perspective, we can move to those launch vehicles. Or perhaps there will be launch vehicles in other countries that we could launch on and have this be an international capsule. Our program is on schedule and budget for the current Space Act agreement that we're working. We've done several parachute drop tests. We've fired the abort engines and the on-orbit maneuvering engines. We got the software running in a lab. It's hooked to our control center and also to the software lab for the rocket. By this fall, we'll have a simulator up and running with a pilot and a loop capability so we can test that. And a significant amount of analysis and design has been done, and we're approaching the critical design review, which will happen next summer. Assuming that we're successful in the competition for the next phase, we'll be doing uncrewed test flights in 2016 of the capsule, and then begin servicing missions in 2017. So it's an exciting time. Frank mentioned a little bit about, so within Boeing, we are 1% of the company's revenue, our human spaceflight business, so it's not a huge part of Boeing, but we're at least 20, maybe 25% of the advertising and pictures that are shown. So, you know, it is, human spaceflight just captures the imaginations of people. It's an incredible recruiting tool, and it's an incredible motivator for the engineers that we need to do all the projects that are done across the whole companies and move into the future. So there's a lot of commitment to working on these programs and making it happen within the corporation. So thanks for your attention.
So 25% of Boeing's budget, and Frank showed the pictures. Okay, it's really an honor and a pleasure to introduce the next panelist, Mark Sirangelo, head of Sierra Nevada Corporation Space Systems. They produce satellites, space transportation vehicles, propulsion systems, and space subsystems. For over 25 years, SNC Space Systems has been engaged on over 400 space missions and has produced over 4,000 systems, subsystems, and components for a wide variety of Earth orbit and planetary missions, such as Curiosity, the Mars Science Laboratory, the hybrid rocket motors that won the Ansari X Prize and that power Virgin Galactic Spaceship 2, and the Dream Chaser space vehicle now in flight test, which will transport humans to and from low Earth orbit. He was formerly the chairman and CEO of SpaceDev prior to its merging with SNC, and has spent his career leading aeronautics, space, and technology companies. Interestingly, and quite differently, for over 20 years, he's been passionately working to make the world a safer place for children. He's a board member and trustee of the National Center for Missing and Exploited Children, and also a founder, vice chairman, and treasurer of the International Center for Children. The centers have resolved over 100,000 missing children cases and have created such nationally known programs as the Amber Alert and Code Adam. In August of this year, in recognition of his efforts to promote innovation, the governor of Colorado appointed Mark as a Chief Innovation Officer of the state of Colorado, a voluntary cabinet position unique in the country. He's also the chairman of the Colorado Innovation Network and the founding and current chairman of eSpace, the Center for Space Entrepreneurship, a nonprofit that supports STEM education and the development of entrepreneurial space companies. Recently, he became a founding member of the Chancellor's Advisory Board for the University of Colorado. we end up appearing at a lot of the same conferences, and whenever we do, he gives me a little grief because he served with distinction as U.S. Army officer. So Mark, I dare you. He has several military decorations to accompany his long list of industry awards and a multifaceted personal background as a long-term licensed pilot. He holds Bachelor of Science, and MBA, and doctorate degrees. Mark Sirangelo from Sierra Nevada.
So I wanted to make sure that everyone here went through scanners and you're not going to be able to throw anything at me. I do have to compliment the security as I was coming through the gate and I showed my ID. They said, sir, we're very happy to see you, but you're about 300 miles southeast of where you need to be. But it is my pleasure to be here and talk a little bit about what we're doing and our program. But I think more importantly, what we all share here, which is a passion for doing what we do in space. You'll hear lots of technical backgrounds. We're all very proud of our different programs. But I think that the main message, particularly for those of you who are coming into the world that we live in, is that this is a really cool place to be. It's a really good place to be. You get a lot of things. You do some things that you never imagined that you would ever do. And it seems like it's so far away from where you all are sitting right now, and I have to say that it isn't. When I first was thinking about getting into this business a long time ago, I imagined what it is that maybe somewhere in my career I might be lucky enough to do one or two things that I really would look back on and say were pretty special, and I think everyone on this panel is doing something that's very special. But for me, there were several things that we've done. I think most recently was the Mars Science Laboratory Curiosity landing last year. Many of you probably followed it and watched it. We, at our company, were involved with the last minute of the 7 minutes of terror. And that became particularly poignant for me as we were all out in Pasadena waiting for the launch, and as you know, there's a delay to Mars, so what had happened on Mars was already gone before we got the video and images. But as we went out there, we were wondering how we were going to see what was going on, and we got there and they said, oh, it was really great news. There's going to be satellites that are going to be able to take incremental pictures of every step along the way as we land. And we're all very happy about that until we realized that meant that we were all going to realize which one of us screwed up, if anything screwed up. So we sat in a room waiting for this to happen, and then it dawned on me that of the 40-some-odd people that companies and organizations responding there, I was the last on the list in front of 400 million people worldwide. But as that happened, and as you all know, we were successful in making that happen. But it really brought to me the poignancy of what we do in space and why this is so important. There's really no way that you can express that feeling of what it's like when something that you've built lands on another planet to look for life or to look for new minerals or maybe look for another place, or the ability to build and conceive a new rocket and get it to be launched, or what Orbital has done just recently in being able to get its first commercial cargo vehicle, or what Boeing has done over the course of its great history. Each of us and people like Blue Origin's team that are putting all their life and money into making this happen. This is not something that we do because we are just thinking of it as just a job. It's a passion, and it's a passion for what we do. Our passion in this particular area, commercial space, started now about 9 years ago. We're the owners and builders of something called the Dream Chaser, which is a orbital space plane, carries 7 people and critical cargo to and from low Earth orbit and brings it back. And much like the history of the shuttle, it is a vertical takeoff runway landing vehicle. And one of the things that I think we all realize, and you'll realize as you get further on into your careers, is that very little in space actually happens through one generation. It's really built on a lot of heritage, and it's really built for people in the future. We are fortunate to have had 135 successful shuttle flights and a tremendous amount of work and effort that went into it, all of which, or much of which, was very relevant to us as we were standing there saying, we think we can build the next version of what an American space plane might look like. But that story started 9 years ago when people looked at me and I said, well, I think there's room here for us as a small private company then based in San Diego to build a replacement for a space shuttle. And most people looked at me like you look at me and say, what, are you crazy? This is long before there was a commercial space program. It was long before the shuttle had even stopped flying. But we looked forward and said, we think it's worth some time and effort because we're going to wake up and realize that despite some of the challenges the shuttle had, it was a magnificent piece of engineering, and it was done for a purpose. And many thousands, tens of thousands of people over its 30-year history contributed to what I think was one of America's greatest achievements. And we heard a lot about it building the space station today, but I think my personal favorite of the missions we can talk about was that it went up and fixed the Hubble telescope. And if you look at the profile of that mission, it took some very audacious people, some very courageous astronauts, a wonderful piece of equipment in the shuttle, and a lot of ingenuity to go up and fix something that now I'm told something in the order of over 80% of the images from shuttle have come post it being fixed. Our knowledge of the universe, our knowledge of what's going on, were made because people took that chance. So we stepped back and said, we think it's possible for us to be able to build what we would build today if the world was going to build a new space shuttle. We probably wouldn't build it in the same way, using the same materials or using any of the same kinds of practices that were done in the 1970s, because why would we? This is 40 some odd years later. But what we did do was we built it on basis of a NASA vehicle called the HL-20, which is a vehicle we originally built to be the lifeboat for the space station. We merged the history and the heritage of the past with what we're doing today. But the purpose of this vehicle, besides going to station and bringing crew and cargo back and forth, is really to set the stage for the next generation of what we're going to do in low Earth orbit. I like to say that my job is to build the systems that are going to enable many of you to build the apps that are going to be able to run in space. It's really about what we do in space with this equipment. It's not so much about the technology. And as a technologist, it's hard to say that sometimes, but that's the truth. We really believe in what we're doing. Our vehicle's gone from being a concept vehicle 9 years ago to being fully built, and the first version of it, our version of what the Enterprise was, is now sitting on a runway in Edwards Air Force Base. And I've done this for a long time, and over 400 space missions, done some pretty good things, and tried to anticipate everything that you could possibly anticipate. Well, the good news is that we were pretty good at it, and we got the vehicle ready to fly. The bad news is I didn't anticipate everything that I could anticipate. No one told me that in the event of a U.S. government shutdown, that the gates of Edwards Air Force Base would be locked and I can't get to my space vehicle to go fly it. So put a note in your books as you're going through school that not everything is there, that there are things that you constantly run into, as we do in our lives, that haven't been experienced before. And as much as we try to anticipate them, we really can't. But assuming the government does get its act together here and they unpadlock the gates, we will be flying our first test flight of our vehicle here very shortly. And it's come a very long way. And in closing, I'd really like to say that the most important thing that you'll be able to feel someday is, I hope what we have been able to feel on this panel is the excitement of taking something that was in your head, a dream that you once had, which is why we call the Dream Chaser, and be able to see it manifest itself into something hardware related that you can touch and hopefully someday get to fly and experience in space. Our goal in doing this was to bring back America's space program. There's so many people like Frank and many of you here who have led the way here, and I feel personally it was a failing of us as a country to let it go where we can't bring Americans to space again. Our program, our view, our focus is to be able to bring Americans back to space on American space vehicles built here in this country. And one of us on this table, or several of us on this table, are going to be able to do that. And that's going to be our proudest moment. So thank you very much.
Thank you, Mark. So our next speaker is Tim Hughes of SpaceX, and I'm noticing a trend. We're going from an Army guy to a lawyer. He is the company's legal, regulatory, and government affairs leader. He joined SpaceX in 2005 as its first in-house counsel and has defined the legal and government affairs functions from the ground up. He's based in Washington. His responsibilities span the company's corporate contracting, export control, insurance, litigation, and launch licensing portfolios, as well as their federal and state government affairs agenda. Prior to joining SpaceX, Tim served as majority counsel to the Committee on Science and Technology in the U.S. House of Representatives. In that capacity, he provided counsel to the Science Committee with particular focus on Space and Aeronautics Subcommittee. He was a principal attorney responsible for drafting and shepherding the passage of commercial human spaceflight legislation and the Commercial Space Launch Amendments Act of 2004, which established a legal and regulatory framework for commercial spaceflight in the United States. He's a graduate of William & Mary Law School and Georgetown University School of Foreign Service, previously worked as a senior associate with communications and litigation groups of Drinker, Biddle, and Reith, LLP, as well as the Office of Chief Counsel for the United States Secret Service. Tim.
Thank you for
Sorry,
that
man.
introduction. I guess. So I'm a lawyer, and I used to work in the Congress. I apologize on both counts. It is an honor to be here today. Greatly appreciate it. Greatly appreciate the opportunity to come address the Naval Academy, especially the midshipmen, and to be invited to be on panels with such a group of luminaries from the NASA family. It really is humbling. When I started at SpaceX about 9 years ago, we were working out of a couple of garages in El Segundo, California. We were founded by a gentleman named Elon Musk. He's a serial entrepreneur, most well known for having founded PayPal, SpaceX, Tesla electric motor car company, and he's the CEO and one of the founders of Solar City. He's my age. And whenever I talk to him, it kind of makes me wonder what I've been doing with my time. But that said, what I'd like to do is tell you a little bit about SpaceX, tell you about our launch vehicles and what we're doing with respect to astronaut carriage. Our company was founded as much on philosophy and intent as it was a sound business case, in all honesty. Elon likes to joke that the quickest way to make a small fortune in the rocket business is to start with a large one. Historically, that has not been a very smart place to put your money. So when I say philosophy has driven our intent, that is very much the truth. And it speaks to the passion that Mark and John and really everybody here today has for space. But that said, it has actually proven to be a fairly sound investment, good for the country and good for SpaceX. Our goals, our philosophical goals, are to increase the reliability and the access to space, drive down the costs of that, and eventually, in the long run, to make humanity a multiplanetary species. That is our core goal. In fact, when you come to SpaceX, if you do come to SpaceX, we certainly invite you to do that and walk around our factories. You see a lot of young engineers, and the dominant outfit that is worn is a T-shirt that says "Occupy Mars." That is, in fact, their goal. That's their raison d'etre, and that's where we'd like to be. And I know that's where NASA wants to be too. We heard at the beginning some discussion as to what commercial space is, and I can tell you what it is not, and that is it is not in competition with NASA. In fact, just the opposite. We hope to be an enabler for NASA, allow NASA to do the bigger things in space, and we hope to speak to these budgetary crises that the country is facing, and we think we've done that to some degree already. So what have we done? Well, since 2002, in our founding, we've grown from 3 folks on the first day to now over 3,000 folks, and we have locations in Hawthorne, California. That's our primary manufacturing space. We have a 550,000 square foot space in LA. And we have made a series of decisions over the past decade when it comes to make or buy. When we analyzed the space launch market to determine what we could do differently to drive down costs and increase efficiency and improve quality, one element was patently clear, and that was in order to do that, you needed to control as much of the technology as possible so that you can control quality and schedule and cost. And so we now build about 80% of our vehicle in-house. So raw materials come in, and rocket engines and rocket stages come out the back. We are producing about 5 rocket engines a week right now, our Merlin 1D engine. We're producing about 1 rocket core a month. So we are ramping up considerably, and to that end, we recently hired the head of production from BMW, who's turned our rocket factory into something that looks more akin to an automotive plant than any rocket factory has ever looked before. In 2012, we became the first private entity to berth with the International Space Station. I had the great privilege of being there actually with Bob Cabana and with Charlie Bolden, and it was an incredibly proud moment for us. Years and years of work went into it, and I actually only have a couple pictures up on my wall. I've got my two little girls, my wife, and then I've got a picture of us on the day that we launched, and it was quite emotional. And it was emotional because it was born of a lot of failure. When we started as a company, we started with a vehicle called the Falcon 1. The Falcon 9 is the launch vehicle we used to berth with the space station, or at least to launch our Dragon capsule to berth at the space station. And the Falcon 1 failed the first 3 times it launched. And the 4th time we launched, as our CEO has now confessed, we were all in. If we had not gotten a success there, we probably wouldn't have been around as a company much longer. But we were successful on that 4th launch, and then we moved on to the larger vehicle, the Falcon 9. And we did that in partnership with NASA, pursuant to a program called the COTS program. And the COTS program was a really innovative program. It created a commercial way of pursuing technologies with firm fixed price payments against milestones, where you only get paid if you complete those milestones. And we and Orbital Sciences have now demonstrated that was a pretty good idea. Because as Michael L.A. mentioned at the beginning of his talk, well, we developed that vehicle and Dragon capsule for about $400 million in the aggregate with government money, certainly matching that with our own money, if not more. The studies have demonstrated that that would have cost somewhere on the order of $1.4 to $1.8 billion had it been done in a traditional manner. So this is a remarkable sea change in the way that these technologies can be procured and brought to market. So on a going forward basis, what we've done with the Falcon 9 vehicle is we had 5 launches initially. We, within a 12-month period, berthed 3 times with the International Space Station with our Dragon capsule. And we've got a series of launches coming up for NASA to carry cargo up and back as well. And we've also up-tuned the Falcon 9 launch vehicle in a significant way, about 50% more capability. We call it version 1.1. And that might be a little bit of a misnomer in as much as we changed the engines and we elongated the tank and we gave it significantly more power. This past Sunday, the same day that Orbital berthed at the space station, same day that the Russian Proton launch vehicle came back on the market after its failures, SpaceX also launched the version 1.1 successfully. We deposited 3 satellites into orbit where they needed to be. And now we move on with our next launch for SES with a satellite that's being built in part by Orbital Sciences. So the whole commercial idea is coming together. What we have overall, independent of the manned launch, and I'll speak to that in a moment, is a series of about 50 contracts under manifest. 60% of those are for commercial entities. So we've not experienced the lack of a commercial market. In fact, when we compete for launches internationally, what we see is Russia, China, and France as our core competitors. And to be honest with you, over the past couple of years, we've started to eat their lunch a little bit on this front. So this used to be a market that the United States dominated, 100% market share in 1980. It dwindled to 0% about 4 years ago, and we're taking back that market. So we're really, really proud of that. On the manned spaceflight front, we're one of the participants in the latest round, the latest iteration on the Commercial Crew Program. It's called CC-ICAP. And what we're doing there is we're taking the Dragon capsule, the same capsule that has now berthed with the space station a number of times. We're putting an integrated launch abort system into it. And these are using 8 Super Draco thrusters. These are engines that SpaceX has developed in-house to create a launch abort system that is, as John said, not a tractor pull system, but integrated. We also think that we'll be able to use this for propulsive landing, deceleration and landing at some point. So we're excited about that prospect. We're working on our life support system. And in the near term, what we're going to see is a pad abort of this launch abort system, an in-flight abort. And then if we're fortunate enough to win the next round, we think we'll be able to start carrying human beings into space, astronauts into space in the 2015 timeframe. So it is a super, super exciting time. We feel like we're making great leaps and bounds for the company, more importantly for the country. And there is one other element that we're really excited about that I did want to put on your radar screens. We've got a project we call Grasshopper. And the Grasshopper is an attempt for us to try to reuse boosters. Right now, when boosters are launched, first stage comes back into the ocean, and it's gone forever. Well, what we're doing now is down in Texas, we've got a first stage with landing legs on it, and we've launched it 7 times over the past 6 months, taking it up to altitudes of about 325 meters. The most recent launch of it was to 200 meters with a 100-meter lateral divert. So we went off to the left, and then we brought it right back down and landed it back on the pad. We're hopeful that these technologies over the next few years will create an absolute sea change in rocket technology. If you're able to reuse these boosters downstream, that is a game changer for sure. And that is what we're angling towards. Our business doesn't depend on it, but it could be one of those things that we look back on years from now and say that's where things changed permanently in terms of rocket technology. So I'm pleased to take any questions when it's my turn, and thanks very much for your time.
Thanks, Tim. The panelists that we've heard from so far have all been involved exclusively in orbital flight, at least as concerns the programs that we've discussed. The next gentleman, Brett Alexander, representing Blue Origin, has a foot both in that camp as part of the commercial crew program, but also in suborbital flight. Brett is the Director of Business Development and Strategy for Blue Origin, developer of vehicles and technologies to enable human space transportation. From October 2009 to 2011, he was a member of the NASA Advisory Council, the NAC, serving as chairman of the Commercial Space Committee, assessing NASA's partnership with industry to develop commercial crew and cargo capabilities to support the ISS and private spaceflight. He's also been a member of FAA's Commercial Space Transportation Advisory Committee since 2008. Previously, he served as a senior policy analyst for space issues in the White House Office of Science and Technology Policy, where he has served both Presidents Bush and Clinton. While at the White House, he played a central role in development of the vision for space exploration announced in January 2004. From December 2006 to May 2011, he served as a president of the Commercial Spaceflight Federation, the industry association of businesses and organizations working to make commercial human spaceflight a reality. And from 2008 to 2011, he was also a consultant in the space industry, providing strategy and business development advice to launch services providers and vehicle developers, as well as assessment of international space activities to NASA. He's also done some work with the X Prize Foundation as the responsible for overseeing all aspects of the Google Lunar X Prize, the Lunar Lander Challenger, and the X Prize Cup, and also senior advisor to a company called T-Space Transformational Space Corporation from 2005 to 2007. He has master's and bachelor's degrees in aerospace from UVA. Brett Alexander.
Thanks, Mike. As you can tell, I can't hold a job, and I've never flown in space, but I have been a space cadet, if you will, a space person, very passionate participant in the industry since I was a little boy. Went to the very first space shuttle launch when I was 13, growing up in Florida. Was very proud to also be at the last space shuttle launch and the last landing as well. So I got wheels up and wheels down on the whole program. And in the intervening 30 years, really got to be a part of the space program of the country in an upfront, up close and personal way, which has really given me a lot of satisfaction. The one thing it has not done is led me into space. I didn't have the aptitude, I didn't have the physical attributes, I didn't have the discipline, I didn't have the dedication to actually become an astronaut. And I want to go back to something that Captain Lovell said this morning when he said at the very beginning of the space program, the Mercury program, they tried to decide, who should go. And at the time, it made sense, the very narrow criteria of folks that they ended up with that should be astronauts. But the time now is to change that. And the answer for now is that everyone should be able to go. And I think those of us on the commercial sector are really working towards that eventuality where not just the elite few that dedicate their careers to being government astronauts get to go, but that the average person gets to go. And at first it'll be the rich average person, like my boss and Tim's boss, but eventually it'll be the average person, just like it was for spaceflight. And I think we share that common goal. One of the things that Captain Shepard also said this afternoon was that the culture of space flight that got us to this point here is not the culture that we need going forward. That has to change. It's different it will be different going forward for expeditionary activities, for routine activities with people going to low Earth orbit and beyond, that our culture has to change to fit with the times. And so with more people going, with the opportunity for everyone to go, we really need to adopt a new culture. And I think you see that both within NASA changes that have come about in the last few years, with industry, both on the traditional industry side and with the so-called new commercial space companies as well. So it's a time of dynamic of change in the industry. I think the future of where we're going to be in 10 years or 20 years is a much more open and accessible space program for the rest of us as well. I think that's good for government exploration as well as it's good for the average person as well. And just a little bit about Blue Origin. We were founded by one of these visionaries. It was founded by Jeff Bezos, from the founder of Amazon.com. As he puts it, he got lucky and hit the lottery with Amazon, and now he has the opportunity to really pursue his real passion, which is spaceflight. He founded the company in 2000, spent a number of years looking at technologies and where to invest money in order to change the game of human spaceflight, because his goal really was about getting more people to fly in space to do more things. It wasn't specific to one planet or to make money. He's certainly done that and certainly hopes to with spaceflight, but it was really about getting more people into space to do more things, to allow humanity to come behind those government explorers that have really pioneered the way for the rest of us. We are laser focused on development of human spaceflight capabilities. We have chosen a different path than, say, some of our colleagues. We have chosen to do reusable systems and human spaceflight systems from the beginning. And as our first increment, we've chosen suborbital flight as a means of practicing that reusability with people on top in order to transition that to an orbital architecture that is both reusable and human-centered from the very beginning. So we hope to be flying satellites and cargo someday, but our plan really is to fly people first. And by demonstrating that suborbitally, it's a lot more cost-effective, at least we believe it to be a lot more cost-effective. We'll be able to have tens, if not low hundreds of flights to prove out that flight heritage before putting people into orbit. The other major difference for us is that while we cooperated with NASA a little bit, we were part of the Commercial Crew Development Program, still are, with an unfunded Space Act agreement. It was funded to the tune of about $25.7 million in the first couple of rounds. Other than that, we are completely privately financed by our founder, and that private financing represents well more than 90% of the company's investment and development so far. And we plan to continue it that way. Not that we don't have plans for revenue or plans for working with the government, but we really are privately financed, and we believe that's the key to commercial. What we do enjoy in our relationship with NASA is access to the tremendous capabilities that they have, the tremendous knowledge and lessons learned over 50 years of human spaceflight, without which we wouldn't be in the business at all. And we've had a really good working relationship with NASA at the various centers and at the headquarters level, and we expect and look to keep that continuing. Fundamentally, we are on a journey that is about changing spaceflight from being dangerous and expensive into something that's accessible to a broader sector of humanity. We view it as a long-term endeavor, something that is 20, 30, 40 years in the making, and we're excited to get moving on that as we have been doing. So we're known as being very secretive. I think the reality is we're actually just very quiet. We like to talk about things after we've done them, not before that. And hopefully you'll be hearing a lot from us in the future. Thanks.
Thanks, Brett. So I have a thematic question. I'm going to kick off some discussion here among the panelists, but what I would encourage you to do is think about some questions you might want to ask, particularly the specific vehicles. Brett didn't mention New Shepard, Blue Origin, because they are a very secretive company, but I'm sure to the extent that he can, he'd be happy to answer questions about that. Tim will answer questions about Dragon. Mark will talk about Dream Chaser, John CST-100, and Frank about Cygnus. So these are the captains of industry before you. I would really encourage you to take advantage of that.
We're like the lieutenant commanders, but okay.
So let me start the conversation this way. COTS is the Commercial Orbital Transportation Services program, which was used to basically develop the vehicles that Orbital Sciences and SpaceX are now using to actually deliver cargo to the ISS commercially. And then CRS, Commercial Resupply Services Contract, was a follow-on buy of the actual services. So I'd like to ask Frank and Tim, and then the others, you can chime in if you like, what do you think are the key lessons to be learned from going from the from the cargo missions to the crew missions in both development and then services?
Tim, do you mind if I go first?
Absolutely.
The Commercial Orbital Transport System was set up as a Space Act agreement between NASA and the companies that were selected. SpaceX was selected first, and then we were selected in February of 2008 to perform basically a demonstration of the capability to deliver cargo to the space station with the hopes that someday there would be a contract to actually provide that service. There's a couple of important things about that that I think are enabling us to do what we're doing, as well as important to the development of the crew transportation. One is they were set up as Space Act agreements, and so the companies involved did have to invest a significant amount of their own money in order to build the systems, to design and manufacture both the boosters and the spacecraft. That's quite a leap, and in this day and age, quite a risk, particularly if you don't have a contract to follow on. Now, the next thing that happened was that NASA did award contracts. Unfortunately, it was to the two companies that had the Space Act agreements already, which allowed us to justify the investment that we had going on to our respective owners and our shareholders, and to justify the level of effort that we were having to put into it, because we knew that someday there would be a return on this, because if we demonstrate it successfully, then we start delivering cargo as a service. For a fixed price, I might add, which is another new way of doing business with NASA. Just like was mentioned earlier, Gemini was important to Apollo. The Shuttle Mir program was important to ISS. It's a little bit different, but I believe COTS is similarly important to CRS and to other commercial support or other commercial services to support the space station. And a lot of that has to do not with just the technology that's developed or the hardware. It's the understanding the relationships that have to be established in order to allow us to do that, the level of requirements that do or don't have to be levied on the contractors, and the amount of communication that has to go on in order to do it safely and efficiently, and do it in a way that, again, justifies what each of the organizations has as its own priorities, whether it's the commercial side or the government side. And I think we've worked through all of that, and I think the success of SpaceX in delivering 3 times to the station, and now we are on board doing that, demonstrates that we worked hard at it. Both companies did, and NASA, on their side, also worked very hard at establishing the right kind of relationship to allow us to do it. It could have become overwhelming, it could have become bureaucratic, but it didn't, and we have some great lines of communication and a lot of trust. And as we worked, and I know that Dragon or the SpaceX folks have had to do the same thing, and all you 3 guys are going to have to do it too. As we worked through some of the issues we had approaching the station, the fact that we were able to transparently tell NASA we were doing what we were doing allowed them to let us do it our way, rather than them coming in and imposing the, quote, NASA way on everything we were doing. Not that it's bad, but it's a lot more expensive in a lot of cases, and so it worked out. So I think it's laid a pretty good groundwork. Tim, you agree?
I couldn't agree more, actually, Frank. And I think one element of, or certain elements of the Space Act Agreement approach can translate over to a more traditional FAR-based approach, and that is the idea that you can do this against a firm fixed price, because you need to properly align incentives for folks. What we've seen when it comes to the manned carriage, the astronaut carriage piece, I think NASA has pursued this in a very smart way. The initial opportunities have tracked with the way that the COTS program worked. That is, that they are firm fixed price, milestone-based Space Act agreements, giving some leeway for the participants to work in an entrepreneurial way. But it has also now evolved to the point where we're transitioning to a FAR-based contract, and that certain elements are actually being treated in a cost-plus manner, because the requirements against which you work have to be known. And to the extent that the requirements are not known, it's very difficult to price those. So when it comes to mission assurance and things of that nature, what we've seen is NASA take a slightly different tack. And when it comes to those things that you work against on a firm fixed price basis, they've taken another. But I think the key element underlying all of this is that you need to work against a set of knowns, and then you can iterate on those as a company, and that's what in effect makes it commercial.
I think I'd just add to that, Mike. I think this has been a bit of a grand experiment in what the relationship ought to be between the government and industry as we work through these programs, and how much insight there ought to be, how much direction there ought to be for the requirements. And it's just important that we tweak those knobs just right as we transition from transporting cargo to transporting crew, so that we give the appropriate level of rigor to make sure the vehicles are safe to transport crew. So we'll just have to watch that as we go through this process.
Any questions from the audience before I move on?
I have one. Every once in a while we hear an event where they have to delay or maneuver the space station around because of possible collision. Is there anything, and you had mentioned about recycling boosters, about cleaning up what we put up there is no longer operational?
Are you asking, is there a program to utilize our capabilities to clean up low Earth orbit?
I'm just wondering, is that part of the, because if we have a collision in space, that's bad, right?
Oh, yeah.
Yeah, so is it getting polluted up there? Is it not polluted? I don't know. It just seems like we have a lot of activity. Do we leave things up there that no longer are used?
I think all of us would support that effort if given the opportunity. It's complicated, expensive, and requires a certain capability, but I think most of what we're building could do that if we had the funding and the wherewithal to do it efficiently. It's not as simple as you might think, as taking a big net or a vacuum cleaner up there, but you could rendezvous with big pieces and deorbit them. We actually had to account for 2 potential collisions during our fly around to the station that affected our timing, just because there's a lot of stuff up there, and the station does have to move periodically.
One of the ways to stop the problem from getting bigger is to make sure that you do the things that avoid those activities going on. And for a number of years now, all of us who build satellites have had the inherent ability to deorbit those satellites and bring them down, so that when they do go dead or they're not used anymore, they're not up there as potential hazards that could cause collisions. So I think there are measures being at least started to keep the problem from enlarging. And then later on, as we get more operational, we'll look at seeing if we can't clean up what's already been up there.
How about another question up here, please?
Now, my question is, when manned flight resumes on the commercial vehicles, how frequent are the manned flights expected to take place on an annual basis?
First, we should specify if you mean orbital or suborbital, because those are very different
Orbital.
answers. Yeah.
I think the baseline right now that NASA's talking about is flights on 6-month centers. Certainly they could go more frequently than that, but that's the baseline that's being discussed.
The NASA mission is revolving around how frequently we want to turn over the crew on the space station. So the idea is that if once the systems are in operation, that they may be able to do more frequent turnovers of the crew, resulting in additional flights. But John's right, the baseline is 2, and we think it might go up from there to 3 or 4 a year as the NASA mission only. And then there certainly are other missions that can be had and will be had by us as we're going, looking at additional markets beyond NASA. On the suborbital side, I know you didn't ask that, but I think that's a pretty exciting part of life. We're building the rocket motor for the Virgin Galactic spaceship, so we're intimately involved with the structure of that. And there are now over 620 people signed up to go on the Virgin flights at 6 people a flight. That's well over 100 flights already booked, and flights are going to be starting next year. So in comparison, there's been less than 600 people from all nations who have gone to space to this point. So it's really does change the idea of how often flights are going to be going, and that's obviously a much more confined kind of flight. It's a day-long flight, but it does indicate that the pace of things is moving a lot more rapidly than they have been in the past.
To add to that, from a suborbital perspective, we're planning tens of flights per year with people on top of it. Certainly less in the orbital at the beginning, but with a reusable system, we would hope to get up to those rates as well.
Is there a question?
The panel mentioned 2 unmanned systems in your discussion. You mentioned the DARPA Orbital Express program, and you mentioned the Curiosity Mars Science Laboratory. Given that this is a conference about manned spaceflight, I still want to pose the question, do you see any commercial advantages to integrating robots and unmanned systems with manned flight operations for future commercial endeavors? I recognize that you're working very hard on some near-term goals and objectives, but are there advantages to working robotics into your systems and your business plans?
Well, actually, for the cargo delivery, we do it robotically, as does SpaceX. And, we have to be human-rated because we're being attached to the space station and approaching it, but it is done robotically and autonomously with the ability to abort as necessary. So that aspect is already incorporated. What a lot of us would like to see as the space program expands beyond low Earth orbit, that if we go to the moon or we go to Mars, it may be too hard, too expensive to get down to the surface, but you may be able to send robotic lander similar to Curiosity, and Mark can use his sky crane again, and we could put things down there and then control them from orbit, or program them from orbit where you don't have the long delay like we do now.
Yeah. A big advantage of so our vehicle is autonomous through flight and docking and departure and re-entry, with the crew being able to intervene as a backup if necessary. And so that kind of a system allows us to have a single pilot and reduced training, so it makes it more affordable as we go forward. That autonomy does.
Up here on the right.
Pilots do like to fly, though, and some of us had to test the automatic carrier landing system in the past, and it got mixed reviews.
Hello, my name is Midshipman 4th Class Moravik. So right now in Johnson Space Center in Houston, there's a NASA physicist named Dr. Harold White, who is working on developing a form of propulsion that essentially contracts and expands space to potentially move vehicles past the speed of light. While we're really far from realizing that technology, I wanted to ask the panelists if any of them would care to comment on what their respective companies are doing in the field of innovation, specifically looking towards propulsion beyond just putting payloads on top of rockets.
Well, I'll comment. We're not breaking the speed of light anytime soon, but we wouldn't need pilots then, would we? No, I don't think so.
They'll get younger, though.
They get younger, yes. Maybe that's a good thing. We could go back and reduce our age there.
That's right.
You and I should collaborate on this. I will say, from an interesting point of view, our rocket motor is somewhat different. It's a hybrid motor system that we've developed that uses rubber as its fuel and nitrous oxide as its oxidizer, so laughing gas and recycled tires. It is, and it does actually work. It was the rocket motor that was used on the Spaceship Two program, first as Spaceship One that won the X Prize, but recently. And in its flight profile, it broke the speed of sound in 8 seconds and went to Mach point 1.4 in 20 seconds of burn using that type of system. So I think there are interesting, innovative ways of looking at propulsion systems, and I think others on the panel here are also doing some good things with motors. But most of us, or at least what we're focused in right now, is to get reliable, safe, predictable transportation to low Earth orbit. And while that sounds a little boring, trust me, it's not. It's a hard job to do, and to be able to do it so that all you guys can get up there and do some real interesting research about how do we break the sound barrier in the speed of light.
I'd say for SpaceX, we've got a propulsion team that is constantly iterating. We've now gone through 4 flavors of our Merlin engine. The Merlin 1D that flew on Sunday being the most recent and the most powerful. But we will, I think you'll see from us within the next year or two, an even bigger engine. We're experimenting with different forms of propulsion. LOX methane is a particular interest to us right now. Again, what you're talking about is downstream, I would say, but I don't think there's any company that's involved here that isn't thinking about the future and ways that we can advance the technology, and we have teams working against that.
And the most of the work we're doing in the space world on propulsion right now is in-space propulsion, electric propulsion being the focus of it. There's a new satellite that we have that uses electric propulsion. It's a lot more efficient, can be smaller. When we start talking of going to Mars or going to an asteroid, electric propulsion, solar electric propulsion is very useful in those situations. Has low impulse, but over long periods of time, and it's weight efficient. And so that's a kind of a focus for the near term, at least.
Well, we may not be breaking the speed of light anytime soon, but when we do, it'll be companies like the ones that are represented here on the panel that will do it. So thank you for your attention. Please help me thank them.
Good job, Dan. As always.
Once again, on behalf of the U.S. Naval Institute and the Naval Academy, we want to thank the members of the panel for doing such a great job. We really appreciate it, and we have a small token of our appreciation for you today.